Hello. So this section 4.3 is all about rational functions. A rational function is something where the denominator has an x in it. They're very difficult for a lot of students, both to conceive and to work with. But the more you work with them, the easier they get, the more comfortable you get. The first example isn't bad. It's a little bit confusing. But it isn't bad. It helps you understand why we would need a rational function, and we're essentially studying things from a single dimension perspective when we're dealing with things like volume, which is 3 dimensions, and you end up working with fractions. But let's forget about that for now. Your skills that you're going to need to remember is that when I have 5 to the half exponent, that's actually equal to the square root of 5. So when you have a fractionary exponent, the denominator is the root, and the numerator is the power. So power up top, root down here. So if I had 5 to the 3/5, for instance, that's equal to 5 cubed, the power, all to the 5 root. And you can do it in either order you want. You can do 5 root first cubed. And this is important to remember for solving certain situations. But that's the power. The only thing you'll have to remember is the exponent. And it also helps when you remember things like this. So they give this as an example as well. That when you have x and x, let's see, what's the example they give? Yeah, it's okay. Yeah, they're different things. X and y, all to the n. That can be rewritten as x to the n divided by y to the n, which also can be rewritten as x to the n divided by y to the n. And it's just to show that the exponent can be attributed to each individual term. You can't subtract them here because x and y aren't the same base. But let's get straight to the problems. It's really, the purpose of these videos is to help you understand how to solve these things, because the more you practice these problems, the more you will be adept. It's not memorizing. It's never about memorizing the methods. Memorizing the methods will not get you a good mark. You've got to then take these problems and apply them. So based on what I've said, what they're making you get used to is rational or fractions as an exponent. So this is the same as, and I said that's the root and that's the power. So this is the same as square root of 49, which is 7. So the answer to that is 7. This obviously is the same thing. Now instead of square root of 400, they're asking for this of 49, they're asking for the square root of 100, which is 10. That's what 10 to the half is. It's not that complicated. Now notice you have a negative, and you might say, well, you can't take a square root of a negative. You're right. But you can take a cube root or a 5 root or 7 root. So this is the same as, remember, this is the root. So a cube root of minus 25. And what number times itself 3 times can reach minus 25? Minus 5. Try it. Put minus 5 cubed, and you'll get minus 125. And that's because a negative number with an odd exponent can stay negative, and a cube root can be done of a negative exponent or a 5 root or any odd root of a negative number. If you're doing an even root, for instance, if I had this, the answer would be unsolvable. You cannot take a cube root of a negative number, or a square root, or a 6 root, or anything. Anyway, next one. And this might be confusing until you remember that 0.25 is actually the decimal 1/4. So they're asking what is 16 to the 1/4? Well, that's the root. 16 to the 4 root. So you got to find what number times itself 4 times will make 16. That's 2. 2 to the 4 would make 16. So the answer is 2. Same with this one. They're doing it again. They just left it in quarter root this time. What number times itself 4 times will make 81? And I'm going to guess it's 3. 3 times 3 is 9, times 3 is 27, times 3 is 81. 3 to the 4 is 81. So the answer to this is 3. And then finally, notice the negative is outside the bracket. And then what they're trying to teach you here is solve your square root before applying this. This is essentially a -1 multiplier. Well, you've got to do square roots and exponents. Square roots count as the exponent rule in BEDMAS. So square roots still apply right here in the E. So that means, what's this 0.5? It's 144 to the half. What's that mean? It means the square root of 144, which is 12. And at this point, you then multiply it by -1. So -12 is the answer. Notice that we took a square root and got a minus answer because the minus was being applied after the square root. Good. Let's see if I got number 2 in here. No, I don't. All right, let's do 2. Very similar. And they're asking you to think backwards now. They're giving you the radical form. And they're asking you to put it in exponential form and then evaluate it. Well, this is a root of 9, which is 512 to the 1/9. Now, interestingly, you would never put it this form before solving it. You would just take your 512, and there should be a square root with a question mark by it, or a square root with a y by it. It doesn't appear I should have one, which is weird. And it might be in the second function here. There it is. So I would take 512, which I already did. I would press the square root with a y in it, and I would then press 9 to tell it to take a 9 root. And I get a 2. So that means 512 to the 9 root is 2. Now notice this would just be an expressive way of writing it. You wouldn't go to this to then solve it. You'd just let your calculator do that. However, you know what? I should not say that. If I take 512 and then hit the X to the Y button, which means I'm going to put whatever my number is to a certain exponent, and I'm going to choose the exponent, and I click that, and then I open brackets, and I take 1 divided by 9, close brackets, and hit equals, I also get 2. So your calculator, you can indeed put fractionary squares to your numbers. So I shouldn't have said that, and you know what? That's how I'll do it from now on. So I'm going to erase them as I go so that I know which ones I've solved. Okay, so this one, it's asking me to write it in a fractionary exponent, and then I'm going to get my calculator. To make negative numbers, you punch in the number, and you hit this plus minus button. Then you put X to the Y up here. Then you've got to open your brackets, otherwise it's going to make the exponent of 1 before it gets divided by 3. And you take 1 divided by 3, close your bracket, and hit equals. And you'll get -3, which means -3, when it's to the cube exponent, would give you -27. So there's your answer. Next. This one's interesting, and it's up to you which order you go in. However, I will express it as a fractionary. So there's a power, so that's 2. And there's a 3 root, so that's to the power of 2 over 3. And I will let my calculator do the same thing. 27 to the xy thing, open brackets, 2 divided by 3, close brackets. See, it's going to give me the fraction in decimals, then equals. And I get 9. So that means 9 is the cube root squared of 27. Now, how would you work that otherwise? You could square it first and then cube root it first, and actually this root turns out to be faster. There is no cube root of 27. Oh, there is. Okay. So you could take the cube root of 27 first, if you want to do it by hand, and that's 3. And then you would square 3, and you get 9. So there you go. That's by without a calculator. Okay, what about this one? What is it asking? So it's kind of poorly written because this square root symbol should be right over it, but they're essentially asking what is -216 to the power of 5 cube root. There's that expression as a fraction. I'm going to get my calculator to solve it. I'm going to punch in 216, press the plus minus button, X to the Y, open brackets, 5 divided by 3, close brackets, equals. It's negative. I don't think I got that right, so I'm going to just make sure. 216 plus minus to the exponent, open brackets, 5 divided by 3, close brackets, equals. Okay, got it right. It is negative 7. Now another way to do it is you could see if there's a cube root of 216, which there probably is. So just forget about the negative for now. I can hit my second feature. And it's 6. So it's negative 6. And then you put that to the 5. And negative 6 to the 5 should be equal to that. That'd be negative 6 times itself 5 times. That's why it stayed negative, is because an odd exponent stays negative, and that's why a cube root is possible, because a cube root can produce a negative. What is this asking? So this is really looks more annoying than it is, but it's the same as minus 32 over 243 to the 1/5, which is also equal to minus 32 to the 1/5 divided by 243 to the 1/5, is which is what they want you to do. So does this number have a 5 root? And I'm going to guess it's minus 2. And does 243 have a 5 root? That's a big question. Does negative 243 have a 5 root? 243 to the exponent of 1 divided by 5. It's 3. And just to make sure on the 32 that the 5 root is indeed 2. Yeah. So it's negative 2 over 3, and you can get a negative because a 5 is an odd root. And finally, this last one is the same thing. So that negative 1 you can resolve right away. An exponent of negative 1 just means flip your fraction. So you get a 4 root of 81 over 16. And that means you can also get 81 to the quarter divided by 16 to the quarter. 16 to the quarter is 2. And this is 3. 3 times 3 times 3 times 3, we already found out. Oh, maybe not. 3 times 3 is 9, times 3 is 27, yep, times 3 is 81. 2 times 2 is 4, times 2 is 8, times 2 is 16. 3 over 2. Both are positive. You might be getting confused by the negative. The negative just means when it's a fraction we flip. If we look at it in the long way, 18 to the negative 1 would simply mean this goes to the numerator and becomes 18 to the 1. And this goes to the numerator, 16 to the 1. And notice, sorry, not 18, 81. But notice that's what we got over here. They just want you to get more and more comfortable with these. So first, right is a single power. They don't want you to resolve it. Always read your question to make sure you save time. So this rule is the multiplication rule. So we add the fractions. They're the same denominator. So I get 2/3 plus 1/3 is 3/3, which is equal to 8 to the 1, which is equal to 8. Now we've got a division, and when it's written like this, you might get confused. However, division like this is the same as putting 8 to the 2/3 divided by 8 to the 1/3, which means I subtract their fractions. They're the same denominator. So 2/3 minus 1/3 becomes 8 to the 3rd. And that happens to also mean, I'm going to leave it like that, but it's also written like this, which is 2. 2 square to the cube is equal to 8. So 8 to the 1/3 is equal to 2. So I guess they just say right to a single power, but if I can solve them, I'm going to solve them. Really, you'd be getting full marks by writing to the single power. So here's the exponent of an exponent rule, which means we multiply these. You get, and notice there's a negative there. So you get negative 30 over 30, which becomes 7 to the negative 1, because we might as well resolve that instead, which is 1 over 7. That's a very simple answer. You could have spotted right away that this fraction up here is the inverse of that fraction, or reciprocal. Whenever you multiply a fraction by its reciprocal, you will always get 1, which is why I like saying multiply by the reciprocal instead of divide or multiply. So remember that whenever you take a fraction and multiply by its reciprocal, you always get 1, and that's because the 27s cancel out and the 3's cancel out. Whenever you're multiplying and dividing, the operations can always be done in any order you want, as long as there's no brackets or anything else in there. So you got, always remember you can only add exponents when the bases are the same. These bases are both minus 11, so I can add their fractions. So 2 3/4 is the same as 8 over 4 plus 3 over 4, which is 11 over 4. And I got minus 11 to that. Now obviously, minus 11 can't have a 4 root. So I question the logic of this. I think, you know, technically maybe we have to take it to the 11 for it, but then even so, you can't, it'll stay negative and it won't have a solution. So actually, I believe this one doesn't have a solution, because you can't take an even root of a negative number, and I shouldn't have that there, that's not there. And you, even if we make the power first, it'll stay negative because that's an odd number. Interestingly enough, you can take that, that's no problem. The problem is right over here. When I cube it, it stays negative, and then a 4 root is not possible. Not possible should be the answer. Here you have same base, so now you subtract their exponents, and sometimes you have to get old school and write it down like this, because you'll notice the bases are not the same. Sorry, the denomination not the same. So let's just cross multiply. So when I cross multiply 3 times negative 1, I get minus 3 over 15. When I cross multiply this way, I get minus 10 over 15. Minus 3 minus 10 minus 13 over 15. So this means this becomes 9 to the minus 13 over 15, which becomes 1 over 9 to the positive 13 over 15. That's not resolvable. This is fine just like this. I mean, the calculator can spit something out. It might be resolvable anyway. I should just see. But anyway, this is a way of expressing it, and that's all the question asks for, right, as a single power. Out of curiosity, I'm going to take 9 and put it to the power of 13 divided by 15. Boom, and I'm going to hit the reciprocal button because it's 1 over. Reciprocal button on your calculator is just 1 over x. Yeah, it's not, doesn't come out to an even number. And finally, this last one. Just rewrite it the way it would be, or solve the first part first. So this first part, we just multiply their, we just add their powers. So we have to add minus 4/5 plus 1/15. We have to convert this to something over 15. Multiply both by 3. Minus 12 plus 1. So you get minus 11 over 15 is the exponent at the top. So it's going to be negative. Divided by 10 to the 2/3. Now I can send this down there and just do the multiplication rule, or I can use the subtraction rule. I'm going to use the subtraction rule because I think that's what they want you to practice. So I have to subtract those exponents. Minus 2/3. Obviously I got a problem over here again. Multiply this by 5, I get 15, and this by 5, I get 10. So minus 11 minus 10, minus 21 over 15. So my ultimate answer is this. To that exponent, which could also be rewritten as this. That's all this negative means. It means put it to the denominator if it's at the numerator, and if it was at the denominator, it would be rewritten up to the numerator. And they want you to just get very comfortable with power rules. Right is a single power. Okay. Then evaluate. So this is 5 to the half. 5 to the half times 5 to the half, which means I add their fractions. Half plus a half is 1. So the answer is 5. So notice the minus 16 can be partially resolved, but I'm just going to put it as minus 16 to the third for now, over 2 to the third. Now notice I can't subtract these because they're not the same base, but I can convert minus 16 to a 2 power. Or can I? 2 times 2, yeah, I can. It's 2 to the 5. It's negative 2 to the 5, I think. 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is, 2 times 2 is 4, 8, 16. I cannot produce that. I can do a weird trick, and I can put the minus outside and say that's 2 to the 5. So what I have, 2 to the 4, sorry. And what I have here is minus 1 multiplying this afterwards so that I get my minus 16 back. And it's all to the third. It's okay to do this. And it's all over 2 to a third. Now I question whether, I think I can do it. Let's see if, I'll resolve them both earlier or later using the long method. What's here, I have to multiply them, so I get 2 to the 4 thirds, all times minus 1, over 2 to the third. What's 2 to the 4 thirds? 2 to the 1 third, I have to subtract 4 thirds minus a third, so I get minus 1 times 2 to the 3 over 3, which is just 1, which is just 2. So the answer I should get is minus 2. Now let's go back and just solve it up here. What's the cube root of 16? What's negative 16? What number times itself? 3 times. It's not 2. It's not 4. It doesn't have a cube root. So I could technically take 16 negative, hit my second function, and take the cube root of it. Yeah, I get a weird number. And then I'm going to divide it by 2 to the power, open brackets, of 1 divided by 3, close brackets, equals, minus 2 is my answer. So notice if we left it like this, it couldn't be resolved. And this can't be resolved. But we can sneakily take that minus out of the situation and resolve it. All right, what's the next one? This one. Okay, so you won't be able to resolve this necessarily as it is. So you get 28 to the half times 4 to the half, which has a solution, obviously, over 7 to the half. And you're not allowed to subtract them because they don't have the same roots. However, here's an interesting rule. 28, you're allowed to break it down inside. And what's 7 times 4? It's 28. You're allowed to then rewrite it like this. So that means up here, I can rewrite that 28 as square root of 7, and it becomes very obvious now, times square root of 4. So that's the 28 times square root of 4. That's the square root of 4 over square root of 7. Now it's very obvious right here that they just will cancel out. And any square root times itself just produces the number inside. However, if I'm going to write it in exponent rules, I get 7.5 to the half times 4 to the half times 4 to the half. And I can only work with the ones that are the base is the same. So these have the same base. Half minus a half, 0. So up top I get 7 to the 0. What's 7 to the 0? It's just 1. So it just pretty much disappears. Here, I can add their exponents. A half plus a half is 4 to the 1, and I get the same answer. However, I actually find canceling it out earlier a lot easier. Okay. This last one's the same trick. If you look at the 18, you're going to discover 18 is 9 times 2 to the 4 root, because the 4 root there, which is the same as the 4 root of 9 times the 4 root of 2. So that means I can replace my 18 with this, and it's multiplying the 4 root of 9 over the 4 root of 2. It's actually the same thing. I could write it all in those decimals. This is smarter. Anything where it's the same root times itself will just be the number inside. If you don't believe me, take the 4 root of 9. So that's to the exponent of a quarter. And multiply it by itself. Oops. Did I get something wrong there? I might have gotten something wrong. Oh, you're right, I did. That is not. Only the square, of course, stupid me. The reason a square root of 9 times a square root of 9 is the same number is because it's a half. You cannot follow that rule with anything more than a number unless, if they were all to the third, a cube root of 9 times itself 3 times, that's the rule, sorry, is equal to 9. And a 4 root, of course, times itself 4 times would be equal to the number inside. No, that was just stupid of me, sorry. Would be equal to 9. But in this case, I got a 4 root of 9 times a 4 root of 9. And I'm going to rewrite it as an exponent to make it more clear. 9 to a quarter times 9 to a quarter. I add the fractions. I get 9 to the half, which is the same as square root of 9, which is 3. Stupid. There we go. So that's that one. Evaluate, which means they want the answer. So clearly, you can't add these. They're nothing. They're not anything, but you can take the results, and I'm not quite sure why they're doing that. This is the same as square root of 49, the same as square root of 16, which is 11. Is there a point to that? Not really. You cannot add roots, whether they're the same base or not. Well, you can do multipliers in front of them, but like I can't add these, except to note that even so, yeah, no, you can't do anything here. They're not even the same exponent. If I had 27 to the 2/3 minus 27 to the 2/3, it'd be quite obvious that's 0. The same number minus the same number is 0. However, this, you could break down the 81 into 27 to the 3/4 times 3 to the 3/4. But there's still no point to that, because subtracting that and that when it's being multiplied by something doesn't mean anything. I mean, there's one of these, but it's not even the same. They're not even the same exponent. So you really would just resolve this. So you could take the square of 27, but the easiest thing is to notice that it's the cube root of 27 squared. Cube root of 27 is 3. 3 squared is 9. So it's easy to see that's 9. And then it's also easy to see that the 4 root, and just this negative is outside. It's -1 times that. So the 4 root of 81 is clearly 3, which is 3 times 3 times 3 times 3. And when we take the cube root of that, it's 27. So what we're dealing with is 9 minus 27, which is equal to minus 18. Not quite sure the point of this, except getting comfortable with the numbers you're working with and what order to do roots. Again, these can't be added together. It should be noticed that you can solve the 4 root of 16 first, though, and get 2 cubed plus 2 cubed minus 1 over 81 to the quarter. 81 to the quarter, we've already discovered, is the same as 3. So this becomes 8 plus 8, which is 16, minus a third, which is equal to 15 and 2/3. If I put that in the fractionary form, I multiply the 15 times 3 and add 2. I get 47 over 3 as a fraction. This is as a whole. This is just as like that, and that's like that. But it says evaluate, which means they want the answer. This, again, you just have to remember your decimal has a fractionary form. So the minus here means I'm taking 1 over 128 to the 5/7 minus 16 to the 3/4. What's the 4 root of 16? 2 times 2 times 2 times 2. It's 2. And what's 2 cubed? It's 8. So we're dealing with minus 8 because that minus is outside. So you're dealing with a 7 root of 128, which I think is possibly 2. So this was a 16 is a 4 root. So 5 is 32. 6 is 64. 7 is 128. So yeah, that's 2. The 7 root of 128 is 2, so I'm left with 2 to the power of 5. 2 to the power of 5 is 1 more than 16, so it's 32. So you're left with 132 minus 8, which is minus 731 over 32. And I could put that in a fractionary form. But why? Technically, if you give any evaluation, you've answered the question. Here we can see that the square root of 3 is 4, and 4 to the cube is 64. Here, 16 to the negative 5 is the same as 16 to the negative half, which is the same as 1 over 16 to the half. The square root of 16 is 4. Plus 8. Here, the minus is outside. The cube root of 27 is 3. The square of 3 is 9. So you get 64 plus 8 minus 9. So you could just even shorten this to minus 1. So you get 63 and a quarter. And yeah, I could put that in fractions if I wanted to. It's 126, 252 plus 1 over 4. I think that's it. Over and over again, these are the same thing. So nothing new here except that this can be re-expressed as a third. But regardless, the answer to that is 2. This is a square root of 81. This you can take the 5 root as 2, and then 2 to the 4 is again 16, so it's minus 16. Here the 4 root is 2, and 2 cubed is 8. So get 9 plus 8, 17 minus 16, 1 plus 2. So it's 3. Write as a single power, then evaluate. So kind of being mean. Here the secret is realizing that that second one is a third. They both have the same base. So you're allowed to add their fractions. Oh, 0.3 isn't a third, sorry. 0.3 is 3 over 10. So now if I add their fractions, I have to convert this to something over 10. So that's 2 over 10. If I add them, I get 5 over 10. So it's 4 to the 5/10. And that means 4 to the half, which means you can simplify that, which means the square root of 4, which is 2. Same thing with this. You just have to remember to convert that 0.2 to 100 to the power of 2 over 10 times 100 to the minus 7 over 10. When I add these, it becomes 2 minus 7. So it becomes 100 to the minus 5 over 10, which is the same as 1 over 100 to the 5/10. 5/10 can be simplified to a half. Square root of 100 is 10, so it's 1 over 10. That's pretty straightforward. You just have to remember that 64 is actually to the power of 1. 4/3 minus 1 is 64 to the 1/3. 1/3 means the cube root of that, which is probably 4. 4 times 4 times 4 is indeed 64. So the answer is 4. Here you just have to get comfortable with subtracting negatives. So they have the same base, so I can take minus 1. And here's the trick. I have to subtract and then minus 2/3. So this becomes a positive. Why? Because the rule for this is I have to subtract their exponents. You have to preserve this negative here because it's part of the exponent. So because minus 1 plus 2/3 becomes negative 1/3. So I get 27 to the negative 1/3, which is the same as 1 over 27 to the third, which is the same as 1 over 3. Here they're doing the tricks with the brackets, but there's a power of a power. So the simplest thing is, yeah, you could just keep them like this and multiply them like that if you want, but the simplest thing is to convert them to fractions. 2.5 is the same as 5 over 2, so you've got 16 to the negative 5 over 2 times, or to the exponent of, and what's that outside? It's 2 over 10, which is 1 over 5. Now I can just multiply. It's not 11, it's 1 over 5. I can multiply these, and I get 16 to the negative 5 over 10, which is 16 to the negative 1/2, all divided by 16 3/4. And the rule is I have to subtract their exponents when it's the same base. What's a half minus 3/4? Well, it's the same as minus 2/4 minus 3/4. It's minus 5/4. So I have 16 to the minus 5/4 is the ultimate answer, which is the same as 1 over 16 to the 5/4. The 4 root of 16 is 2. So we get 1 over 2 to the 5. 2 to the 5 is, I believe, 32. 4, 8, 16, 32. Yeah. So 1 over 32, positive. Here again, they're just making sure you can convert those decimals to fractions. Up top, it's 8 to the minus 2 times 8 to the 5 over 2. Nice thing is you can just multiply it. The 2's cancel out, and you get 8 to the negative 5, because it's negative 2 times this positive, divided by this 0.65 is just a quarter. 6 times a quarter is 6, because it's an exponent of an exponent, is 6 over a quarter, which is the same as 3 over 2. The rule for fractions is I take minus 5 and I minus 3 over 2. I have to best convert that to, I could just quickly see that that's 1.5 though, minus 1.5, and see that it's minus 6.5, which is this. How do you convert that? You just double it. That's the same as minus 13 over 2. So I'm left with 8 minus 13 over 2. Might have made a mistake there because these are usually solvable, and I got a square root of an 8. So I'm going to go back and make sure. So up here I have 6 times a quarter, which becomes 6 over 4, which becomes 8 to the 3 over 2. So I got that correct. And up here, I could just multiply them if I want, and it gets 8 to the negative 5. So I got that correct. I have to subtract their exponents. Minus 5 as a fraction of 2 is minus 10 over 2. Minus 3 over 2 becomes minus 13 over 2. I got it right. So that means it's 8 to the power of minus 13 over 2, which is the same as 1 over 8 to the 32. over 2, and I guess you're allowed to use your calculator. So I'm just going to take the reciprocal after. 1 to the exponent of, close brackets, 32 divided by 2. No, that's not 32, is it? It was, was it 13? I think it wasn't 32. I think I wrote that one down wrong. 13 over 2. So that's the same as 1 over 8 to the 13 over 2. So I'm just going to take this and then hit reciprocal on my calculator. Clear it all up. 8 to the power of close brackets 13 divided by 2. Close brackets equals, and then hit my reciprocal button. And I get 1. So I think they wanted it as a fraction. So if I take it instead as a fraction, it becomes pretty weird. I mean, I guess I could say that, oh, look at that, it's very small. It's to the exponent of negative 6, so that's 10 times to the exponent of 36, which makes sense. So 8 to the power of 13 divided by 2. I think they might have made a mistake on this, or I did. I don't think I made a mistake, though. It's 1 over that. So I don't know about that. Why did they throw that one in? Whatever. Sometimes you just got to go whatever. Teachers make mistakes. Everybody makes mistakes. Textbooks make mistakes. Predict the order of these 6 expressions in terms of value from lowest to highest. Predict? We'll have 4 root of that. Let's say we'll work with 600. 10 times 5 times 5 times 5. That's around 5. Because 5 times 5 is 25. Times 5 is 125. And times 5 would be 250, 300. Oh, and another 5. So 5.5 around. 25 times 5 is 125. Oh, times 5, that's 600. Yeah. It's around 5 point like 1. The 10 root of 10, what number times itself 10 times will be equal to 10? Geez, like 1.1. Oof. Cube root. What's the 8 root of that? 2 times, it's around 2. 2 to the 5 is around 32. The 5 root of that. Oof. Number times itself 5 times. 5 times 5. That's 5 is 3 times. 2 square. Oh, God. Around 3 square, around 9, I'm going to guess. And then this one, what's the 4 root of that? 3? 3 times 3, 9. Yeah, it's around 3. What's that? It's around 7. What's the square root of that? What's the square root of that? It's around 4.5. And 4.5 cubed is around 264. It's around 80. So in order, this. And if you really wanted to figure it out, you could do your calculator and solve it. Check your answer with your calculator. Yeah, I'm not going to bother. It's semi-useless exercise. They just want you to get used to approximating, because then you can catch mistakes. Okay, these are word puzzles. Students always have trouble with word puzzles, which is transforming words into the equations, right? Makes sense. The volume of the cube determine the length of each side. So a cube is like a square. All the sides are the same length, which means x times x times x is equal to the volume. They've given this as a volume. So that's our volume, and we know that's is equal to x times x times x, which is equal to x cubed. To solve this side, I have to take the cube root of x cubed, which means I have to take the cube root of this number to get the sides. So if I take 0.01562, I can either make it to the exponent of a third, or I can take the cube root as 3. And I get 0.25. So x is equal to 0.25. Then I got to go back and see if there's units. If there's units, I would say meters. And just remember, one dimension has one exponent, If I was working with a surface area, that's 2 dimensions, so it would be meters squared. And volume, oh yeah, they do meters cubed, so it's 0.25 meters. And volume, you'll notice, has cubes, because volumes is 3 dimensions. So always remember to match your units with what you're describing. Since I'm describing a length, it's going to be in meters. Use your calculator to determine the values of this. What do you notice? Okay. Let's just think about it carefully here. This is 27 to the cube root, which is 3, to the power of 4. 3 times 3, 9 times 3, 27 times 3. It's 81. This is the same as, this 1.333 is tricky. It's the same as 1 1/3. That's what 0.33 is, which is the same as 4/3. So all they're doing is giving you the same question. This is going to be a little bit more accurate because we always end up losing a decimal when we put it to this. What do I notice? My calculator gets inaccurate the more I use inaccurate numbers. Explain why 1 is possible and 1 is not. Okay, so the secret here is convert your exponent, convert your decimal. So this is 10 squared. Oh, is it possible? Oh. 0.2. 10, sorry, that's 5 over, sorry, 1 over 5. There we go. That's what 0.2 is. The reason it's possible is because I'm taking an odd root, a 5 root of that, and when you take an odd root of a negative number, it's possible. This, however, 0.5, is re-expressed as negative 100 over 1, 2. 1, 2 is a square root. You cannot take a square root of a negative number. You can take cube roots, 5 roots, 7 root, 9 root, odd roots, but not even roots. You can't take a square root, a 4 root, a 6 root, or an 8 root of a negative number, etc., etc., etc. That's why. It's obvious what they're asking. Write it in radical form. Okay, first thing to solve is that negative. So it's really 1 over 125. Radical form means write it with the square roots. This is the root. This is the power. You can put the root first and the power inside. Or you can put the power first and the root inside. Doesn't matter. So that's what it is. And there, I would just stop there. The resolution of that is 125 cube root, I believe, is 5. And then squared is 25. So it's 1 over 25, which is 0.04, I think. 4%. That brings a good point, actually. Do you realize that 4% is just a way of saying 4 parts per 100, which is the same as the decimal, 0.04. That's what percent means. It means 4 parts out of every 100. That's why 4% expresses a decimal, is that. Evaluate. This is all calculator. So they want you to get used to punching in your calculator of that. Now, it would be possible to express that as a fraction, actually. It would be minus 256, 375 over 1,000. Now, interestingly, if you did it this way, I guess this minus is outside, because otherwise they would have put it as brackets. You can't do it if this minus was inside, because that's an even root. However, it's an odd power, so it's interesting if I'd powered it first. No, it's still an even root. So it shouldn't happen. Or it's interesting if that was an even power, if I could make it positive first and then take the root. But anyway, they're saying the minus is outside of this. Easier just to 256, put it to the exponent of 0.375 on your calculator, and then apply the negative or apply the negative n squared. The textbook is never very clear when they want the negative in the exponent or not. There's several ways you can do it. You could just punch it in your calculator like that, or you can just take 0.0277 and put it to the 4/3 in your calculator, to the power of 4/3. I'm not going to do any of that. Same with that. Same with that. That is the same thing. You just take that number and take it to the 3/4. That's the root. That's the power. That's the power. That's the root. And same with that. You don't need me to do that. That's just getting you comfortable with your calculator, and you should get comfortable with your calculator. Faster you get in your calculator, more time you save. Well, it doesn't mean 4 multiplied itself 4 times. If we were to re-express that, that would be 5/2. So how we would write that as in words is both two ways. Square root of 4 multiplied by itself 5 times, or 4 multiplied by itself 5 times and square rooted. And that's how you would describe it in the similar terms that they ask for. I urge you to do these questions yourself. The idea is that you should stop the recording when I do a question and then try the rest for yourself. And then if you confirm the right answer by continuing to play. This is false. You're not allowed to do that. This is very easy to see if you take numbers that are solvable instead. Well, look, they are solvable. That's why they gave it to us. What's the 9 to a half? It's 3. What's 4 to the half? It's 2. What's 3 plus 2? 5. 13. What's the square root of 13? It's certainly not 5. This might be true. The easier way to rewrite this to figure it out is to rewrite the internal as this, which means I can just now flip my fraction, which is indeed the right side, so it's true. This might be true. No, wait. Plus? That's interesting, because they change it to multiplying here. It'd be interesting if it is. If it is, I think it's more coincidental. This 5? No, can't be, yeah. 18, 36, square root of 36 is like 6. Not true. And those never should be true. Oh, keep in mind that this is times itself 6 times, so it's very unlikely it would produce that. You cannot add them together, and you cannot apply the 6 cubed individually, because this is really this bracket times itself 6 times. You're going to get all sorts of distributing issues, because you've got to distribute it times the second term over and over and over again. Proving this would be very difficult, because they're trying to make you do this. They're trying to make you apply the exponent over here and make it 6/3, which becomes squared. And they're trying to make you apply this to that and make it squared. That's not true. This bracket, when it multiplies itself, produces a gazillion terms. Not that. So this is the same as this. You can't add these together. Well, you could if we put them on the same denominator. So I have to multiply this by b over b. So I get b plus a over ab, all 1 over. And I'm trying to get to this, keep in mind. To solve this, it essentially becomes the reciprocal. And we can see that that's not that. Now, when it becomes multiplying, yeah, you can follow the rules. So this 6 can distribute individually to these things because they're multiplying. So 6 times a third becomes 6 over 3, which becomes x squared. And this 1/3 becomes times y squared, which is equal to x squared, y squared. So yes. So getting you more and more comfortable with what rules work and what rules will not work. 15, 16, 17 are all extension. It's always good to try your extension. Keep in mind, don't feel bad if you can't get the extension. I've had some calculus extensions that I cannot get, and even when I see the answer, I'm like, I suppose, but I don't know if I could have derived it on my own. So, when can't this be possible? Well, when n is an even number and m is an odd number. So that's when it's undefined. Undefinable? There's no values of m and m here that would make it undefinable. Oh, n can't be 0. But anything else is fair game. Yep. That's the only one. The only reason is because you can't have a fraction up here that's 0. Other than that, any possible m and m is possible. For this one, because you can't take a square root, 4 root, or whatever of a negative number. However, if this was even, it would make it positive. So I have to say, well, when m is odd, n can't be even. So to phrase that, when m is odd, n can't be even. That's about it. And it might even be that n can't be even. But it's interesting. What will my calculator say? Because my question here is, if I take a negative number and I make it to the 4 over 2, I know I can't square root that 5, but does the power of 4 take over first? I mean, I know it's clearly minus 5 to the 2 here, but I'm just seeing if what my calculator will say. If I take minus 5 and put it to the power of, yeah, it's going to solve it though. So let's take minus 5 and put it to the 7 over 2. I think it's going to solve it because it's just going to resolve the fraction into a decimal. No, invalid input. So because the 7 kept it negative, the 2 couldn't, even when expressed as 3.5. So that's good to know. The question is, if I make it an even number, like, see, the problem is this 2. Let's make it 4. So it's still not supposed to work, right? And we'll make this 18. The reason I'm questioning it is this 18 has the potential of making that positive. Yeah, so it does work. So when there's an even number up here, it's okay to take a square root because this even number can make that positive. So this is a possible solution. So this was a correct way of expressing it. When m is odd, n can't be even. Well, they can be 1 for sure. When x is 1 and y is 1, this is true. When you think of it, this is a growth curve. No, I think they only meet in one spot because this is a reciprocal, and so the reciprocals will be mirrors, and so no. Only x and y can be equal. To give you an idea of that, well, 1 is very clear when it's 1. Anything else? 2 to the 1 is equal to 1 to the 2. Nope. Zeros don't work. Oh, when they equal. Whenever they equal. Because 5 to the 5 is the same as 5 to the 5. So this will always work, always be true when x is equal to y. Graphically, is there a way to find it graphically? I mean, I don't know if Desmos could handle that. Whew. Look how crazy that is. Yeah, so some things can't be resolved. Graphically, it doesn't really resolve it for me. I'm not sure how you would do that graphically, because I have an x and a y axis, and I need one variable to be true. I guess I could make x to the y equal 5, and the other one equal. So if x to the y is equal to 5, it's the same as saying y is equal to 5 over log 5 divided by log x. So x would be the same thing. I don't think that'll work either. Now I'm going to take that and just switch their values. Do they ever meet? They meet at one point. So I'm going to take 25. See if they meet at 5. No. They meet at 0. Weird. I would know. Actually, see, there's a good one. Graphically, I can't wrap my head around it. But definitely when x equals y, the solutions are true. Mary must solve this equation. Yeah, it's not a bad suggestion. If you take a 12 root of both sides, you're resolving this. So you get 1 plus I is equal to the 12 root of 1.225. And then I is equal to that minus 1. Now the problem with that is you're going to get a negative number, because 1 plus I, 1 to the 12, well, let's take 1.225 to the 12 root before I say that. Yeah, you get lower than 1. Oh, no, I didn't. It was higher than 1. So you get that, and then I subtract 1. Yeah, you get the interest rate. There it is right there. The interest rate is this, which is equal to 1.706%. Small, but accurate. To test that out, let's plug this decimal here back into there. Yeah, of course it's going to work because we just did it. It does work. It works and it makes total sense. In future, what you end up doing for more accuracy, like obviously this is solvable, but sometimes you're going to have an exponent up here that you can't solve. So you're allowed to take log of both sides. Actually, no, that's not needed in this case. Our solution is totally legitimate. Ugh, really? So what's the 4 root of 16? It's 2. 1 over 2. What's the cube root of 8? It's minus 2 over 3. And they want to know what they're telling us that it's going to be equal. By the way, this is just x, and it's the absolute value of x, really. But let's just leave it like this for now until we solve the left. Is this possible? We'll see. What does this become? 1/2 is the same as 3/6 minus 4/6, which is minus 1/6 is equal to x squared. Square both sides. You get 1 over 36 is equal to x squared. Square root both sides. X is equal to 1/6. The problem with this is if I take 1/6 over here and square it and then square root it, I will not get a negative number, which is what this side is. So you actually have to apply a negative in front and say x instead of is equal to -6. You have to say, oh, I forget how you do it. I think you have to say, like, I don't think it's technically solvable because of this. Oh, actually, yeah, it is, because when you take the square root of both sides, you have to add a plus or minus. So since the plus doesn't work, so it's really plus or minus the square root of x. And since the plus doesn't work, it would be the minus. So the answer would be minus, the answer is minus the square root. X can't be -1/6. You have to somehow put a minus in front of this equation. Weird one. It's only because the result here is negative and the result here can only be positive. I'd be curious what the book says. I should pull up all the answers to the book before I do it. So here we have to isolate, because mathematically it comes up with an answer, but logically it doesn't work. So here we should just isolate this first. Since it's negative, let's just move it to the other side. So you get x to the 4, which is clearly just x. So it's the same problem here, though. That's creating a positive number, even when x is negative. Is equal to the cube root of the 8th, which is 1/2, minus the 4 root of 16, which is 2, plus 15. And minus 2 plus 15 minus is plus 13, 13.5 is that. And 13.5 is the same as 27 over 2. So x is equal to that. I believe that works. So the secret would be putting it in the Desmos and seeing if Desmos can solve it. And you just put it all on the same side and you put y or 0 is equal to it. Or Symbolab would be good for that, to see what that it says. I believe that's it. Yep, 4.4 is next.